Okay, number one, an observer stands from a launch site, okay, which is 200 meters away. So let's say like that, and the air balloon rises vertically, going up, right? So let's say this point, okay, let's say in distance from the ground is y, and it's going up, and that speed is 4 meters per second, and kind of we can imagine that direction is positive, so the velocity of that balloon is 4 meters per second, right? And how fast the angle, so the observer is watching that balloon is rising up, and that should be the angle, let's say it's theta. Then how fast the angle, so that's the magic word, so we are looking for d theta dt, and at certain time, right? And the balloon increases 30 seconds after the launch, okay? So the time is spent, okay, after 36 seconds. They don't give us the actual heights of the balloon, but they only giving us, okay, how long it's going to take, because the balloon actually grounded in the beginning, right? Okay. So from that given information, we should get the relation between theta and y, right? Because there's the two unknowns, and we are looking for this theta dt, and we know what the y dt is. So if we get the equation for theta and y, we can take the derivative of it. So then what is the relation between these two? So this is a right triangle, therefore tangent theta equals y over 200. And because we are looking for d theta dt, let's just take the derivatives. One thing we should know is we don't need to take the inverse of this one, right? So like arc tangent y over 200 equals theta. No, because of the chain rule, we can take the derivative of it directly. So derivative of tangent theta with respect to t is secant square theta and d theta dt by the chain rule, right? And the right hand side is actually 1 over 200 times y. It's kind of linear function. So derivative of it with respect to t is 1 over 200 and dy dt. Okay, so what is dy dt? That is 4. So right hand side is going to be 4 over 200 is 1 over 50, and that's what we are looking for. So eventually d theta dt is 1/5 times 1 over secant square theta, which must be 1/5 times cosine square theta, right? So eventually we need what cosine theta is, right? Okay, we know cosine theta is like that, right? So it's going to be 1/5 times 200 over whatever the hypotenuse is and make it square, right? So we just need to that. And how can you calculate this hypotenuse? Temporarily, let's say that is capital H. And we know this is 200 and that is H, but we need to get that one. So we need to know what Y is at that specific time. So it says at 30 seconds later. So when the balloon is rising up with that speed for 30 seconds, then where the balloon is at the time? 4 times 30, right? So it's going to be 120 meters at the specific time. So we are looking for the hypotenuse when the bottom is 200 and that height is 120. Okay, so that h must be square root of 200 squared plus 120 squared by the Pythagorean theorem. So that should be the answer.